1, is that right? Yes? Okay, so if you want to verify, like you're taking a quiz or test, before you even turn it in, you can check to see if it's right. And that's just by plugging it in to both of these. So you want to see is 5 times -3 minus a -1, is that equal to -14? If it is, then you're halfway there. So like -15 plus 1, that does equal -14. So it checks out with the first equation, but then you want to check the second one. So is 8 times -3 plus a -1, is that equal to -25? Okay. And you get -24 minus 1, which is -25, so it works. So you can check before you even turn it in, before here's my test, here's my quiz. You can know what your grade is before you turn it in. So do that on each as needed. Grades are coming home soon, so if you get those grades and you realize they're lower than you'd like, this would probably be a good thing to do to raise it, is know your grade before you turn it in and fix it before you have to turn it in. Okay, so moving on. So this is something you can do all the time, whether it's graphing, substitution, or elimination. So do a quick warm-up. Looking at this, what would the answer be if you distributed all the way across all 3 times? Just give an answer to yourself. Now notice the parentheses around the entire equation, so we have to do 1, 2, 3. Right, D.
Oh, I didn't see that.
Okay. All right. Ready? Ready? So, just want to show you where we've been and where we're going. Okay, so we did graphing. Remember, that's the answer where they intersect. But that could take a while, especially if you don't have a graph. Okay, and if you have fraction answers, you're not going to be able to look at that and say, oh, it's these 2 decimals. So, not always reliable. We also have substitution, which works if you have something that's y equals or x equals. And you have elimination. That's what we just started this week. Remember, this is all the same problem. I can solve any problem the same exact way. I mean, all 3 ways I can solve it. So these are just different ways of doing the same thing. Okay, so this is where we started before. You're looking to see if a variable will eliminate by adding. In other words, equals 0. So the first few days, they always did. You plugged it back into either equation, got the other answer. Okay. And you can now know how to do a check. You can always plug it in, get the other answer. So you can always look at this and say, okay, is -1 plus 6? Yeah, that equals 5. And is +1 plus 2? Yeah, that equals 3. Just by plugging it in, you can see mentally, okay, it's the right answer. You don't have to go past it without checking it. You can do it very quick. Yep. We didn't do anything like that. Okay. Now the question comes up, what happens when we get here? How do you use elimination? Because if you start just doing this, nothing eliminates, right? You get 3x and you get -1y, nothing eliminates. The whole purpose is to have either the x's or the y's cancel out and equal 0. So I mentioned this when we first started, that eventually they won't be the same number and we'll have to do something, and that's today. So what you're going to do is you're going to look at this and say, well, if this is like a 2x, what would I like to have here that would cancel out with positive 2x? What would be good to have right here? -2, right? And you start thinking about, okay, what can I do to cancel it out? So I'm going to multiply this entire equation, kind of like we did in the very beginning, multiplying the entire equation by the number that's going to let me cancel things out. So if I keep the top the same here, right, but the bottom I multiply everything by -2, so -2x, +8y, and -18. Now it's an equation that you can cancel out and eliminate. So that's the only thing that's new today, is trying to figure out, well, which equation, top or bottom, do I multiply by what number? So you got to pick an equation and pick a number, and you got to know what to multiply by. Okay? After that, all the same. So you can just go through, carry on like we always have. Again, the answers will be nice, even numbers. So if you get a fraction for the rest of the week, this is a mistake, stop there, go back, try to find what's wrong. Don't just keep moving on and say, well, it's a fraction, therefore it's no solution. By the way, even if it is a fraction like this one, if you solve it, the answer can be a fraction. So don't say it's a fraction, no solution. It's very possible for it to be a fraction. It won't be like that today, but don't say no solution. Okay, go back and find what the mistake is. Okay, by the way, on here, you notice that I could cancel out the x's by multiplying the top one by -1. Then that way I'd have a -2x on top and a 2x on the bottom. That equals 0. Or I could multiply the bottom equation by -1, and now the top would be 2x and the bottom would be -2x. Or I can multiply the bottom equation by 5, and that cancels out the y's. So that's really 3 different correct ways of starting this problem. So if your work does not match somebody else's, but you get the same answer, it's perfectly fine. There's just multiple ways of doing it right. Okay, so don't just stop because they're not identical. Yeah.
Can you do it with 2x?
Yep, you can do 3 different ways. That's one of them. So you multiply by -1 and either top and bottom, and it'll cancel out. Okay? All right, so let's practice a little bit of that. Let's go down to 3. Okay? Now let's look at this. Now, which equation or which variable would you like to cancel out? The x's or the y's? The x's. Okay, so if we have a +18 here, that means I need a -18 here. What can I multiply by to get -18? 2, right? Because then I'll have 2 times -9, which will be -18. So I'm going to multiply everything by +2 all the way across 3 times. Okay. Top equation stays the same. Doesn't change. But now the bottom, 3 times you're going to multiply. So 2 times -9 is -18. That's what we wanted. 2 times y is 2y. And 2 times 26 is 52. And now it's just like a problem from Monday, Tuesday, and Wednesday. You can eliminate and finish it. So this is the only thing that's new. It was picking which equation, top or bottom, and then choosing the number to multiply by. So we can finish that up. That's 0. 2 plus 2 is 4. 52 minus 20 is 32. And then we can divide everything by 4, get y equals 8. So I have half my answer. I have the second part of the answer. It's going to be something common 8. And now plug that back in into either of the original questions. Don't plug it back into like the one we multiplied and got, but one of the original 2 that are printed on the paper. Top or bottom doesn't matter. So I can do 18x plus 2 times y, which is 8, equals -20, and finish it up. Yeah, the bottom one, yeah. Doesn't matter which, same thing. Oh, that's 16. That's why. Negative 36. There we go. And just now, I noticed that I had 38, and 18 doesn't go into 38, so I stopped and I thought, wait a minute, something's wrong. I went back and I saw, oh, 8 times 2 is 16, not 18. So as soon as you see you're going to get a fraction, don't just keep going and say, well, I guess I can't do it. That means there's a mistake, and you go back and you find it, correct it, and now 18 does go into 36 evenly. Negative 2 times, so my answer is negative 2 comma 8. So it will always come out even. If it doesn't, stop and go back, find a mistake. Don't just keep writing or, write something that's not true, like no solution. Okay. Okay, let's go down to 5. Yeah, 5. And once again, ask, what variable do you want to cancel out, the x's or the y's? Yeah. Okay, if we want to cancel out the x's, if this is a negative 15, this needs to be what number? What number do we need here? Well, we need a positive 15, which you'll get by multiplying by 3. So we need a negative, we have a negative 15, we need a positive 15, so multiply by 3 to get positive 15, and do it 3 times. Okay. So we have 15x minus 3y equals 15. Top just stays the same. Negative 15 plus 3y equals negative 13. Now, what happens when you add these together? We get 15 minus 15, which is 0, but we also get 3 minus 3, which is 0. So the whole left side just is 0. No variables. So that's a hint that if both variables cancel out, we have a special case. 15 minus 13 is 2. Now, well, now what? We don't have any variables. We just have 0 equals 2. What does that mean? Right, well, 0 is not equal to 2, right? That's false. 0 and 2 are not the same number. And if you have a false statement, that usually means a no solution. Okay. Now, do you remember what happens on a graph when you have no solution? Right? There is no answer. So how can two lines not have an answer? How can two lines not intersect? Yeah, so if you look at them very carefully, yeah, those two lines, if you graph them, are parallel. That's why there's no solution, because they don't intersect. The intersection was the solution. No intersolution, no intersection. So they're parallel lines. So just remember, when you get a no solution on elimination method, if you graphed it, that's the same as parallel. You don't necessarily have to know the slope of the y-intercept, but you do know they must be parallel because there is no answer. The lines don't cross. Okay, and of course, the opposite of that is, if you got like 0 equals 0, that would be true because 0 does equal 0. And the counterpart to true is infinite. Solutions. Okay. So this is not this problem, but later on, if you happen to get the same number on both sides, it could be 3 equals 3 or 5 equals 5. It's the fact that it's equal, it's the same, not that it's a 0 and a 0. So the same number, true, different numbers, they're false. And what does it look like if it's infinite solutions on a graph? Okay, it looked like this. Right? There's actually two lines there, but it's the exact same line. So you see how they're the same line. That's why it's infinite, is because they overlap and they intersect at every single point an infinite number of times, infinite solutions. Right? So that's what it looks like graphically when you have an infinite. But if you don't have a graph, you just have to see, well, if it comes out to be true, same number, right? That just means same number. That means if you graphed it, they'll just overlap at every single point. Okay, lastly, just on number 6, what would you multiply by? Top equation or bottom equation, and what would you multiply it by to start that problem? All right, so choose a variable, x or y. What are you going to eliminate? X. All right, so if you have a 14, what do you need here? You need a negative 14. So to get negative 14, multiply by 2. And that's really the only part that's new. The other common mistake is some people like to do just the first two distributions. Don't forget the other side. It is the entire equation. So both sides, including the right side and everything in between. Okay. All right, so your goal is to first finish anything else from Wednesday, Tuesday, Monday. Get those stamped, turned in. Start and finish today's, and then we'll either have a Khan Academy or just a catch-up day tomorrow, depending on how we do. Okay. So go ahead and work the entire period to get everything done.